Yes. All right. So first, I'd like to thank Benoit Gauthier for putting together this event. It's really a pleasure to be here, and I've had a lot of interest in the various presentations. So thank you so much. And secondly, the actual title of our paper is Concept Utility. This is a joint work with Cahal Madagain from Leipzig. He used to be in Paris actually 2 years ago when we started exchanging ideas on this topic. He will soon come back to Paris to work with my colleague Brent Strickland. I should say that so the topic of this paper is, since it's about principles of epistemology, I thought presenting a talk on concepts would be interesting. So we actually have been interested in instances of conceptual revision. So it's a fact that we sometimes revise our concepts, and the focus of this paper is actually on sort of natural kind terms, although you might wonder whether it's generalizable to other conceptual terms. But so an example of a conceptual revision is, for instance, when Linnaeus, or Linné, the famous Swedish naturalist, assigned whales to the category mammals instead of fish. That happened between 1756 and 1758, between two successive editions of the Systema Naturae. Mark Sainsbury has a nice little paper about the sort of vagueness or ambiguity of the word fish in legal contexts, mentioning this. A more recent example is the discussion by Mike Brown, the author of this book, How I Killed Pluto and Why It Had It Coming, of how he himself was in doubt as to whether Pluto was a planet before he himself and his team discovered a number of celestial bodies, pushing gradually to the decision, or I would say consent among scientists, astronomers, not all of them though, that Pluto should not be a planet, and that the category of a planet should be reconceptualized or revised. So that's what the paper is about. And basically our starting point is that there is a puzzle in conceptual change for standard theories of concepts. They're not really adequately equipped to deal with conceptual revision. Not that anything we're going to say would be incompatible with the theories in question, but that they are not really giving any detail or even sketch of the way in which conceptual revision might occur among experts. So one of the leading views is the sort of the internalist, let's say, family of theories of concepts, on which, for instance, horse could mean, if you're descriptivist, let's say the things that I'm trusting here. Cahal, this is Cahal's description, not mine, I think. The things that Winnie, I think we share that race at Cheltenham, I'm not so sure. That stem their feet, have manes and long tails. But you've got other, let's say, incarnations of this internalist theory. If you think that, really what we store in our minds are sort of prototypes or best exemplars, depending on the case, or even sort of theories we internalize in one way or another. So all these views make it hard to think that if really some conceptual revision is taking place at some points of our intellectual history, this is, as it were, because we might be mistaken about what our descriptions intended to refer to. I mean, that might happen in the same way possibly in which, some descriptions might be flawed. If you think of Donnellan cases of, descriptions where you sort of misdescribe part of what you intend to refer to. But it's arguably not the kind of revision that is taking place when we revise our concepts. So different line of thought is to think that really concepts are, the meaning of concepts is what experts really use the word that we use to trade with those concepts to refer to. So horse, on that view, would be the things that the word horse refers to according to the best experts. And then it's more promising because we can be mistaken about experts' use. On the other hand, again, if we focus on the experts themselves, let's say in virtue of the way in which social externalism is defined, there's no clear, let's say, sense in which the experts could be mistaken themselves. So something else must be going on at the moment that the experts are revising, and we would like to capture that. So you may think that, yeah, the third view is the sort of natural kind externalist view, on which horse now refers to the set of things that share their intrinsic nature with that particular, let's say, instance of the concept. And there, things are fine because we can be mistaken about the natural boundaries of that set of things, let's say, sharing the intrinsic nature with a given thing. So in principle, this allows for conceptual revision. The problem is the theory, as it is laid out, does not explain what counts as a natural boundary. So you may think it's not really the burden of the theory to account for that. But again, I think here the goal of the paper is to try and say something about the ways in which, let's say, some delineations between concepts might be more natural than others. So if I have to rephrase this, I would say that we intend in this paper to characterize the relative betterness of conceptual schemes compared to one another. And we're working in the framework of this sort of broad family of theories which involve some notion of epistemic utility. So as Roger Pouvet was mentioning, in reference to a comment that Julien Duton was making, you can put this, if you wish, under the sort of the umbrella of epistemic consequentialism in a broad sense. But I will try to be precise as to what we mean by epistemic utility here. Of course, you know, the notion could mean so many things, so the goal of the paper is also to articulate the notion. So in the first part of this paper, I will give some background on what epistemic utility refers to for the kinds of theories we started off with. And I will explain how we can define the notion of concept utility. And then, so this part of the talk will really be drawing an analogy between propositional belief and what we can call utility for propositional beliefs, and the conceptual level. And once we have that material in place, I will try to show you how to make the account work on a toy example. So basically part 2 is about objects and properties and the idea, in line actually with the sort of externalist theories of conceptual content, is the idea that, you know, if we revise at all our concepts, it's in the light of new objects coming up in our experience, but also in the light of new properties becoming salient in our experience. So I think even if you don't buy the epistemic utility part of the talk, you should agree that a good theory of conceptual change should have the resources to let's say, to describe expanding domains of objects and properties. So that's the second aspect of the talk. And then the third part of the talk will be something that actually initially motivated me independently to think about concepts. This was the case of the revision of the concept planet by the International Astronomical Union in 2006. I think so. This will be used as a sort of application of the account. And I think the case has drawn some attention from philosophers, but I think has been partly misdescribed. For instance, by David Chalmers in a paper 2011 called Verbal Disputes. So if what Cahal and I say is right, there's more than verbal disputes behind the sort of reclassification of Pluto, for instance. All right, so let me talk about epistemic utility first. We have this very plain build-up, which is, asking what makes a concept useful, and think that, we use concepts to form beliefs. So to know what makes a concept useful, we should also think about what makes a belief useful. And one answer is that beliefs are useful if they are plausible. The term plausible, I've noted, has been used in a number of different senses, but I think all of the senses, even in Alan's previous talk, as having a relation to truth. So let's define plausibility as, for a belief to be likely to be true, or if we trust Williams' famous description of the norm of belief aims at truth, right? And I don't mean to commit myself to truth being exactly the right standard, right? Or exactly the right norm. So this in relation to Davide's talk, but just to be at least, right? So it might be that we need more, but we need at least, truth to be the norm. Now, you will grant that, but you may also note that plausibility cannot be the sole measure of epistemic utility. And another constraint we have on our beliefs is informativeness. So an example that we take from a discussion that Patrick Meyer gives in the Philosophy of Science is the example of Cavendish accepting and stating that the electrostatic force falls off as the nth power of the distance for some n between 1.98 and 2.02. In fact, Cavendish could have accepted the electrostatic force falls off as the nth power of the distance for some n between 1 and 3, so thereby making his description less precise, less informative, but also more plausible, right? So you see that by being less informative, obviously you gain in plausibility. And in fact, we know there's this other line, or there are those two lines in the literature in the philosophy of confirmation. On the one hand, the idea that the business of confirmation is to find plausible theories, the other line being that it's to find informative theories. This tension between informativeness and plausibility is, for instance, discussed in a paper by Franz Huber, trying to combine the two virtues or the two aspects in what he calls a plausibility informativeness theory of confirmation. I would say that the tension is also described in this paper by Russell on vagueness, 1923, where Russell aptly notices that, or notes that possibly one of the virtues of vague language is to increase the plausibility of our utterances. But also, of course, in Grice's work, when we compare the maximum of quality and the maximum of quantity, So quality obviously tracks truth and also, in fact, justification. If you read the maxim fully, quantity tracks informativeness, and the relation between the maxims is not obvious, and the fact that we need both is a sign that we would sort of be misdescribing I would say a number of aspects of language use just using one of those two maxims. So if we have to give a simple picture of the situation, we would say that in practice we accept the most informative belief that meets our need for plausibility in a context. Okay, so that shouldn't surprise you. Again, as I said, if you have a proposition that is fully plausible, it will be completely uninformative. If you try to be maximally specific, you might end up being very implausible. So the difficulty in a context is just to find the right balance between the two constraints. And the way in which we try to transfer this talk of informativeness versus plausibility from the level of beliefs to the level of the building blocks of beliefs, namely concepts, is to think that informativeness and plausibility of propositions co-vary with two features of concepts, which we call inclusiveness and homogeneity. So I'm going to describe them. Let me start with inclusiveness. So if you think of the relation of informativeness between propositions, so let P and Q be two propositions. P is more informative than Q if and only if P rules out more possibilities than Q. Now, when you consider concepts, there are two concepts, C and D, which is going to say that a concept viewed extensionally, right, C is more inclusive than a concept D if it's a superset of D, okay? So just to give an instance of the relation we have in mind, the proposition all whales eat krill entails the proposition blue whales eat krill, and therefore the universally quantified proposition is more informative, right? Prima facie, if you don't know anything about whales, but know that there are blue whales, so it's less likely to be true. But on the other hand, it makes the statement stronger, right? So it's more informative. But you can see that as the generalization is stated, blue whales is indeed a subset of the set of all whales, right? And so in the same way in which the concept of all whales is more inclusive than the concept of blue whales, the generalization based on that concept, in this case, right, with sort of positive nuclear scope in this quantified sentence is more informative. So far, so good. Now, if we go to homogeneity, here our idea is that plausibility increases with homogeneity. So just think of propositions again, irrespective of concepts. A proposition P is more plausible than proposition Q means, by definition, that P is more likely to be true than Q. Now, if you think in terms of the relation between concepts, it's a little more involved. So you need to specify a set of what we will call features. So let's fix a single feature, F. We're going to say that a concept C is more homogeneous than a concept D relative to that single feature F, if and only if the proportion of C members sharing the feature F or not sharing it, depending on whichever is greater, is higher than for D members. So since this definition is more abstract, I'm going to try and illustrate it. So again, think of the, assume that there are only blue whales and black whales, right, in the domain. So you know that the probability of the conjunction blue whales and black whales eat krill is just, will be less or no more than the probability of just one of the conjuncts, right? Blue whales eat krill. But if you think of just the, now the relation between the set of all whales and the set of blue whales, and if you were to think of some features like being blue, for instance, obviously the homogeneity of the set of whales relative to that feature being blue is less, for instance, than the homogeneity of the set of blue whales relative to the feature blue, because all blue whales are blue, not all whales are blue in this case. But now, this is one of the, let's say, supposing this is one of the relevant features that we have to talk about whales, ceteris paribus, blue whales and whales, seen as the set of all whales, share all of their other features, right? So you're bound, you're bound to decrease the homogeneity of the superset concept relative to the set of all features. Obviously, when you go to an individual concept, right, it should be perfectly homogeneous relative to whatever feature you've specified in this case, right? So that's another intuition you can rely on. So for instance, if you take Jacques and I, right, relative to, I don't know, the color of our eyes or the color of our hairs, we form a heterogeneous set, right? But if you now separate us into two singletons, we become completely homogeneous relative to the same features. And again, being homogeneous means that you can perfectly fail to have the feature in this case, or perfectly have the feature. The problem is when things get split, right, over a set of individuals. So if you want the more complex definition, I don't know if this is readable, by the way. The resolution doesn't seem great. Might be a feature of my setup. But once you understand the notion of homogeneity relative to a single feature, you can talk of homogeneity of a concept relative to a set of features. So definition 4 here gives you, it says, if you fix a single feature, you've got a set of objects, and the worst thing that can happen is that, half of the objects in the set have the feature, the other half doesn't have it. So the sort of lowest number initially for homogeneity would be 0.5. Think of just finite domains, right, to make things simple. So we want this 0.5, which is the sort of minimal value, to be rescaled to 0, right? And on the other hand, when all the objects share their features together, we want that to be 1. So there's a way of rescaling this measure of homogeneity. And if you now have a set of features, we can calculate pointwise the homogeneity of a concept relative to each of the features and then average over the set of features to get a measure of homogeneity of a concept relative to a set of background features. So now what you see coming up is that a theory of the homogeneity of concepts cannot work in a vacuum. We need to have features in the background, right? So that's an important aspect of the phenomenon. So again, if I summarize, those are simple ideas, maybe overly simple, you'll have to tell me, but basically there's this trade-off between informativeness and plausibility. Again, all whales eat krill is more informative than blue whales eat krill. It's also less plausible. We see that the concept of whales is also more inclusive than the concept of blue whales, but it's also less homogeneous. All right. So given those considerations, the need for an optimal trade-off between plausibility and informativeness in the case of propositions, or inclusiveness and homogeneity now in the case of concepts, can give us a hint as to how best to conceptualize a domain. And the way we propose to define concept utility, so this is probably the central slide in the talk, is to give, just think of utility as the product of inclusiveness by homogeneity. So again, if you fix a domain of objects, a set of features, and a concept which actually can be, ought to be thought extensionally, we can calculate again the epistemic utility as a product of inclusiveness and homogeneity. And since we know that these features sort of contra-vary, there will be ways of comparing the relative utility of various concepts or various ways of carving out a domain of objects into different concepts. Okay, so you can think of the pragmatic maxim in this case as carve out your concepts in such a way as to maximize concept utility. All right, so this is basically the leading idea, and I want to spend the rest of the talk explaining how it might work on first some specific examples. So I'll just show how what predictions we can get out of the model, and for that I need to talk about objects and properties. So what I here call properties is what I used to call features in the previous case. I think it helps to distinguish features and concepts, because really features are sort of unary properties, whereas concepts can be multidimensional. So let's think of properties as, you know, if you wish, unary properties. So think of an environment now as an object property matrix. If you look at the literature on concepts, for instance, Smith and Medin's book, Concepts and Categories, 1981, lays out the exemplar theory of concepts in terms of those object feature representations. So we should think of the objects in this case as particular exemplars in their theory. So O1, for instance, has the feature F1, it has feature F2, F3. O2 is like O1 except on F1, right? It lacks that feature. And O3 has feature F1 but lacks F2 and F3, okay? And the idea is that if we start off with that set of objects and that set of features, we can wonder how can the domain be partitioned into several concepts in an optimal way. So given the, for instance, here is a more maybe concrete example. Suppose you have 3 sea creatures in this case, and you look at the features blowhole, dorsal, having a dorsal fin or not, having a certain aerodynamic profile. Those 3 sea creatures might have those various features or not. And we know that we can conceptualize the group in several ways, meaning that we can decide to partition, in this case, the domain into various concepts. So we're going to think of a conceptual scheme really as a taxonomy in the sense of a partitioning of the domain into various concepts. Now, if you think of it, in this case, we have a trivial partition, which is just lump everything under a single concept. But of course, you can split, right? Separate out the first 2 from the third, or the other way around, or just extract the middle one from the first and the third, or finally go to the finest partition, which is have 3 individual concepts. And those are the 5 partitions you can think of in this case. Now, given the definitions we have, we should just work out the definition of concept utility on the various examples. I'm not going to do this on the 5 partitions, but I'm going to do this on 2 of them. It's very simple. For instance, if you think of the first partition, so what's the inclusiveness of the concept? It consists of everything, right? So the measure of inclusiveness of the concept is 1, right? Because the proportion of objects falling under the concept in this case is everything, so it's relative to everything is 1. No mystery here. Now, if you think of the way in which we could calculate homogeneity of the concept relative to each feature. So let's do this without rescaling first, right? So what's the homogeneity of this all-catching concept relative to the first feature? It would be that you see that 2 out of 3 individuals have that feature. So it would be 2/3, and you see that the same happens in the second feature and in the third feature. But in fact, as I said, we want to rescale 2/3, right, to an interval between 0 and 1. So if you rescale this, you multiply by 2 and subtract 1. It means that, in fact, the relative homogeneity of the concept relative to each feature is, in fact, 1/3. When you average out, it remains 1/3, right? So now what's the utility of the partition? It's just the product of 1 times 1/3. So we know that the utility of the partition now is so something I haven't defined, but we can also think that utility of a partition is the average of the utilities of the building cells of the partition. So it will be, in this case, 1/3 again. And if you compare this with the utility of the second partition, so now things are a little more complicated, but not too complicated. In the case of, right, the first concept includes the first 2 sea creatures. The second has only the third in it. So obviously the inclusiveness of the first concept is 2/3, the second 1/3. And now if you calculate the homogeneity, again, you should do it step by step. So you see that the homogeneity of the first concept relative to the first feature is 1 out of 2 individuals having the feature. If you rescale this, it will be 0 homogeneity, because in this case, the concept is maximally split, right? Just the way Jacques and I were relative to hair color, sorry. And likewise, so if you go on to check the homogeneity of the concept relative to the feature's dorsal fin or aerodynamic profile, then the 2 objects fully agree, right? So the homogeneity will be 1 in this case. So when you average out, it becomes 2/3. And if you look at the second concept, as I said already informally, this is an individual concept, so unsurprisingly, the homogeneity is maximal. So now, if you look at the utility of the first concept, you get 4/9 of the second concept, 1/3. And if you average out, it becomes 7 out of 18, which in fact is slightly greater than what the utility of the first partition was. This is a toy example, right? So the numbers are not spectacular, but still it shows that at least the prediction is in line, right, with our expectations that those first 2 individuals have more in common, right, with each other than the third has with any 2 of them, or with 2 of them to group together. So in fact, if you do this calculation for each and every partition, you will see that P2 is the optimal partitioning compared to P1, P3, P4, and P5. Okay, so now what's the benefit? We want to talk not just about partitioning, but also about conceptual dynamics. So if as I told you, we know how to assign a score of inclusiveness to concepts, a score of homogeneity. But now we want to look at the effect of discovering new properties and new objects, which are arguably the sort of leading external factors into making conceptual revisions. So again, we can work out the toy example. Discovering new properties will, so think now, we're discovering this property of having mammary glands, giving live birth, having gills. We get an extension of the description of the domain. We have the same set of objects, but now we have a richer description of them. And so we can, again, we can update, basically, the utility scores that we had at the previous step. So now if we were to compare, for instance, the utility of P2, the second partition, which we saw was optimal in the previous case, to the utility of P3, for instance, this will be a case where actually just splitting out, so sort of grouping the first and the third individual becomes more optimal than just keeping the first two together. So if you had defined initially now a concept or a conceptual scheme sort of intentionally, right, as by a certain kind of implicit rule, which you think should be conservative over the initial domain you had, then you will see that the scheme becomes suboptimal in terms of utility. And likewise, you can think of the same effect of discovering new objects, but keeping the set of properties constant. So we had initially, we had those three objects, but we can think of a different example in which now we have this very homogeneous group of those first three creatures, and the fourth has only one property in common with them. So now if we calculate the utility, you will see that in fact grouping everything together remains more optimal than splitting them, which may seem to be a bad result, but at least it's a prediction, right, of the account. The things will obviously change, right, if you gradually find more representatives of the second, or I should say of the fourth individual type. So suppose we now have three of them. Obviously now this is a case where the domain again is sort of maximally heterogeneous. So now splitting the domain into two groups is more optimal than just keeping everything together under one concept. Okay, so again, this sort of green partition wins over the red partition. So as I said, it's a very simple idea. But if I, just to summarize the interim conclusions, you see that first point, we can assign concepts a score of epistemic utility based on those notions of inclusiveness and homogeneity. Second point is we can assign partitions viewed as conceptual schemes, epistemic utilities based on the utilities of the concepts that they consist of. Based on that, we can define a preference ordering on the conceptual schemes. And finally, we can explain in principle why some schemes get to be revised with the discovery of either new objects or new properties. So now I would like to illustrate this on a concrete example. By concrete, I mean not just, putting pictures to tag a matrix consisting of zeros and ones, but really sort of starting off from the case, from a real case, a real sort of a science case, which is this interesting case of the revision of the concept planet. So with some of you were talking about this over lunch. You may know or remember that Pluto was discovered in 1930. At the time, the concept planet extended from 8 to 9 objects. What is interesting is that as early as 1930, Pluto was described as being some kind of oddball in terms of some of the relevant properties it had relative to the other concepts. So for instance, it was known as early as 1930 that it has a very significantly tilted orbit relative to the other celestial bodies. This is described in this paper by Frederick Leonard. We also know that it's more distant than the other bodies, but that's probably not discriminating because we're not expecting them to necessarily be equidistant. We also know that it has this particularly icy feature and so on. What is interesting is that it didn't occur at the time to split planet into two categories. In fact, if you look at the history of astronomy in the 19th century with the discovery of so-called asteroids, it had occurred as early as the discovery of the biggest of them, Ceres, to immediately think that it was not on a par with the other planets. Okay, so there's nothing really amazing in what I'm describing here. But what I find interesting and misdescribed in a lot of this, I would say, whether in the popular science reports on the demotion of Pluto from the category of planets or from the philosophical discussions that I've seen, is that the demotion of Pluto from the category planet did not come just from, you know, a group of people meeting in a big room like here and just deciding to vote, is this a planet or not? There was this paper by Stern and Levison, two astronomers in 2000, regarding the criteria for planethood and proposed planetary classification schemes. And what is really interesting about this paper is that without knowing, they do the sort of natural counterpart of the sort of family resemblance observation that Roche and Mervis did in their 1970s papers on concepts. Namely, looking at a range of potentially defining criteria for planethood, which you see in the table here. So in order to be a planet, do you need to have satellites? And then they each time come up with counterexamples. So in this case, for instance, Venus and Mercury do not have satellites. Having an atmosphere, again, you know, finds counterexamples. Having a magnetic field has counterexamples. Moving against the stars, which was in the past centuries a way already of revising the concept. They find exception to, and so on and so forth. And if you look at the line behind the table, they conclude, indeed, we find that no single criterion can adequately define the conditions for planethood. What I find interesting is that they don't rest, they actually don't propose to do something like a, you know, let's calculate the family resemblance score of of each of these objects, including Pluto and the other ones, and decide, you know, we're going to draw the boundary somewhere based on the family resemblance score. They did come up with, in fact, two criteria for planethood. So one is what they call in their paper a geological criterion. And basically, I myself, you know, I'm deferring to the experts here. So their idea is just if you have a certain round shape, if you can sort of sustain what they call hydrostatic equilibrium, then you're a planet in the geological sense. And then they come up with a dynamical criterion, which is very close to what the International Astronomical Union put forth as the discriminating criterion for planethood. So in the terms of the IAU, it became having cleared the neighborhood around its orbit, meaning, you know, having aggregated sufficiently many things that are in the orbit of the celestial body. And in fact, in the ways in the statement of the IAU, it sounds very qualitative, but in fact, they are serious people. They come up with a quantitative criterion. And they show that this criterion, according to them, is discriminating. However, according to them, by both criteria, Pluto is a planet. It's just by the second criterion, it could be subcategorized as what they called an unterplanet, in their words. And the International Astronomical Union decided to call Pluto a dwarf planet. Now, what is worthy of interest for us is that by 2000, if you think that all this science was there, and they had identified a feature, a new feature, right? This feature of having cleared the neighborhood around its orbit. By 2000, Pluto was still a planet, according to them, because despite the other odd features, it had probably the other main features, right, shared with the other celestial bodies. So maybe orbit shape, and so on and so forth. So what happened was that despite the discovery, as we would want to describe it, of this new interesting feature, there was not yet a sufficient number of objects instantiating the new feature for that to really change the conceptual scheme. But if you look seriously at what happened between 2000 and 2006, the year of the convention of the IAU, in 2005 there was the discovery of this celestial body now called Eris. So Brown was the main discoverer with his team. It's a Pluto-like object. It has very similar properties to Pluto, both in terms of size, shape, and so on. And it actually was discovered in the wake of the discovery of a number of other smaller objects in the same region of the solar system. So eventually, the IAU decided that they would split eventually the category planet from anything that contains Pluto, and Pluto would become the prototype, as they call it, of a new category, being a trans-Neptunian object. So that's sort of the picture of the solar system that we're supposed to have now. So if we just, to simplify, if we just think that, having cleared the orbit, where initially the one discriminating feature of interest, you could describe the case as being a case where, as in 2000, we could already have split, right, the celestial bodies into 8 planets versus Pluto. But if you do just a blind calculation, right, relative to that feature, you would find again that it's less epistemically useful to actually split the concept than just to keep a single category. On the other hand, if you now include in the list the sort of main celestial bodies that were discovered until the IAU convention happened, then the homogeneity was damaged by the discovery of those new bodies, and therefore it became beneficial to split the category into planets and something else. Okay, so that's the sort of argument or the empirical support we try to draw from a real case to suggest that inclusiveness does play a role. So let me go, to leave time for discussion, to my conclusions. So as you see, this is a theory of concept utility which gives us a way of comparing conceptual schemes along 2 dimensions, inclusiveness and homogeneity. We can use it to rationalize conceptual revision, and we can explain a particular case, the case of planet, as a case where a property only became operative once sufficiently many objects made it problematic relative to homogeneity. There are objections you can make, of course, and I think probably the one you anticipated is an objection that already was voiced against all this literature and concepts, whether for prototype theory or exemplar theory. You talk about features, I talk about features or properties, but the account here does not explain how features or properties are selected in the first place and how they even are weighed in the first place. So I've given an account where, first of all, homogeneity and inclusiveness carry the same weight. Maybe that's disputable, but more than that, even the various features that we've talked about are equally weighted. We don't need that, right? You can see very easily that the account could be just elaborated along the lines of giving extra various different weights to different features. It would just become the weighted average then of the utilities that you get out of that. So if you think about this you may wonder what's really explanatory about the account here, but I think we should talk about this. Then I want to mention some perspectives quickly. I'll just take 1 minute. I've mentioned how epistemic utilities, a score of epistemic utility can be assigned to concepts and to partitions. The problem is, can we sort of extend this normatively to hierarchical taxonomies where you have, really a hierarchical structure of partitions embedded into partitions? This is not so easy. So I can give you an example. I actually wrote a program for the paper. It's very simple, right? Because as you can see, the arithmetic behind this is very simple. But just if you start off from a taxonomy like the one you have here, you may. So we are able to calculate the utility of each of the concepts that we have here. So you start out from birds, you've got the dark birds, the bright birds, the large dark birds, and so on and so forth. They give you, concepts or partitions that are at different levels. And the question for each of the, of the concepts, you can find a score of epistemic utility. But the problem is, how would you assign now epistemic utility to the whole partition? And you've got extra degrees of freedom, right, in the way you could do this. You could do this level by level, average over the levels, or find other measures. In fact, this is what we thought we should do first, and we don't necessarily get the right predictions in this case. And it's not obvious that this is the way also that, taxonomies get to be tallied descriptively as opposed to normatively. So again, this is sort of future work that I'm interested in exploring. And that's it. Thank you very much.